Hello everyone, welcome to another video. Now let's solve for the value of x. Okay, we are given 17 raised to the ln x equals 34 minus x raised to the ln 17. Okay, now to solve this question, we're going to use one of the properties of logarithms. Okay, one of the properties of logarithms, that is using the logarithmic property a raised to the log b log base b of c equals to c raised to the log base b of a. Now we can prove this, we can prove why this is equals to this. Okay, now let me quickly explain why we have this to be equals to this. Now let's say I choose a letter from the alphabet to represent this. Let's say I choose letter P to represent a raised to the log base b, okay, of c, and q equals to c raised to the power of log base b of a. Now I'm going to take log base b of both sides. Okay, taking log base b of both sides, this will be log base b of p equals to log base b of a raised to the power of log base b of c. Okay, and I'll do the same thing with this other equation. Log base b of q equals to log base b of c raised to the power of log base b of a. Now, this is where we can now apply another property of logarithms. That is the product rule for logarithms. That's product rule. So in this case, so if I'm using the property log to base a of b, that is log to base a of b raised to the nth power. This will be equals to the product of n log base a of b. So which means for this one, we're going to have log base b of p to be equals to log, this will become the multiplier. So we have log base b of c multiplied by log base b of a. That's for the first one. Okay, so for this other one, this guy, okay, so we're going to have log base b of q equals to, this will be log base b of a multiplied by log base b of c. Now let's look at what we have for the two logs. Now we can see that log base b of p equals log base b of c multiplied by log base b of a. Then for log base b of q, okay, log base b of q equals log base b of a, which is what we have here, multiplied by log base b of c, which is what we have here. So which means that log base b is equals to log base b is equals to log base b of q. Okay, so which means that p is equals to q, and this is how to show that this, okay, when we have a raised to the log base b of c, okay, will be equals to c raised to the power of log base b of a. So we're going to use this property, okay, to solve this question on the given question. So we have, from what we have given, we have 17 raised to the power of ln x equals to 34 minus x raised to the power of ln 17. Okay, now let's say I want to apply this log, okay, this property applying it to this x raised to the power of ln 17. Okay, so we know that using this property, if we have x raised to the power of ln 17, then this would be 17 raised to the power of ln x. Okay, so I can now write this equation to be 17 raised to the power of ln x equals to 34 minus 17 raised to the power of ln x. So now I'm going to combine like terms. So I'm going to carry this over to the left hand side from the right hand side, and it will become positive. So 17 raised to the power of ln x plus 17 raised to the power of ln x equals to 34. Now we combine like terms in this case. So this will be 2 multiplied by 17 raised to the power of ln x equals to, because we have 2 of this, equals to 34. Now, if you divide both sides by 2, okay, so this will be 2 parentheses 17 raised to the power of ln x equals to 34. So I'm going to divide this by 2 and also divide this by 2. So this will reduce to 17 raised to the power of ln x will be equals to 17, because 34 divided by 2 is 17. So now we can now apply one of the rules for exponents. Okay, so we have same base on both sides. So the exponent of 17 is 1. So this will reduce to ln x equals to 1. Now let's not forget that ln x is the same thing as log base e of x. So which means log base e of x is equals to 1. Okay, now I'm going to take base e of both sides. Okay, taking base e of both sides. Taking base e of both sides. So this will be e raised to the power of log base e of x equals to e raised to the power of 1. And then we can also use one of the properties of logarithms using the statement that a raised to the power of log b to base a. This will be equals to b. This is another property of logarithms. So in this case, we have e raised to the power of log base e of x. That will be x. So the value of x is e. So the value of x is equals to e. And that is the value that satisfies this equation. Now let's verify our answer. Let's verify. Now the given equation is, we have 17 raised to the power of ln x equals to 34 minus x raised to the power of ln 17. So now the left hand side is 17 raised to the power of ln x. Now the value of x is e. Okay, so we have the value of x to be e. So this will be 17 raised to the power of ln e. And this is same as 17 raised to the power of log base e of e. And we know that log base e of e is equals to 1, which is also one of the properties of logarithms. So in this case, 17 raised to the power of log base e of e will be equals to 17 raised to the power of 1, and that will be 17. So this is the left hand side. Now for the right hand side, okay, we have the right hand side is equals to 34 minus x raised to the power of ln 17. Now we have that the value of x is equals to e. So now I'm going to substitute e for x in this expression. So this will be 34 minus e raised to the power of ln 17. Again, we know that ln 17 will be log base e of 17. So this will be 34 minus e raised to the power of log base e of 17. So now we can now recall this property of logarithms, or this property of logarithms, that a raised to the power of log base a of b is equals to b. So which means e raised to the power of log base e of 17. Okay, that will be equals to 17. So this will be 34 minus 17, and that will be, so the right hand side is also what? 17. So verified. So which means the value of x which satisfied this equation is e. I'll see you in the next video.